we can transition into our first panel for the day. And I'd like to invite John Goldstein, Jeremy Freeman, and Elizabeth Riley on up. And we're going to start with John Goldstein. So John is Senior Director, Regulatory and Legislative Affairs at Environmental Defense Fund. And John leads EDF's efforts to improve regulation in the oil and gas industry and protect air and water resources at the state and federal level. Prior to EDF, John was Secretary of the New Mexico Energy, Minerals, and Natural Resources Department and Deputy Secretary of the state's Environmental Department, among many, many other interesting roles. So thank you so much, and please join me in welcoming John.
Thank you. Morning, everybody. Thanks for that. It's great to be here with you today. I am going to talk a little bit about MethaneSAT, which is, I think really builds from what Kyle was talking about, which is, how remote sensing can make what has been a colorless, odorless gas, invisible to the naked eye, visible and actionable from a policy perspective, which is what I work on in Environmental Defense Fund. So let's see if this works. Great. So methane, I say that and folks are like, why do you care about cows so much? Or, stop messing with my dairy cows or my beef cows. It is true that bovine, sources are important. What I actually work on, though, is methane from oil and gas development. So, methane is a very powerful greenhouse gas, more than 80 times more potent than carbon dioxide in the short term at driving climate change, and is responsible for more than 25% of the changes in the climate that we're already experiencing. So for those of us like myself that are concerned about climate change, want to do all we can to try and change the trajectory of this problem in our lifetimes, methane is a very powerful way to do that. Oil and gas is the largest industrial source of methane pollution in the United States. And in addition to being this sort of climate super pollutant, methane is also the primary component of the natural gas that we use to cook dinner, to heat our homes in many cases. And so efforts to limit the pollution of methane also is a net benefit for energy. We have more energy that we're keeping in the pipeline that can be put to productive use. And then thirdly, methane leaks at oil and gas production sites come with other problematic forms of pollution as well. So when you're capturing that methane, when you're plugging that leak at an oil and gas well, you're also stopping leaks of volatile organic compounds, which are one of the main building blocks of ozone pollution, or commonly referred to as smog. And also carcinogens like benzene, things like that, things that we don't want to be exposed to. So it's sort of a triple win, really, from the climate, the energy, and the public health perspective. So MethaneSAT is going to be launched early next year, and it'll mark the first time that an environmental nonprofit has launched a satellite, which is very exciting. But it's far from the only satellite up there, and will not be the only satellite up there that detects methane. It's just going to be an important additional tool in the toolbox. EDF started this sort of science journey on trying to understand methane emissions about a decade ago. And at that point, and this has continued on through today, there has been a lot of fuel switching going on in the electric generation sector, from coal to natural gas. And a lot of that's being driven by just the straight up economics. Natural gas has dramatically decreased in price in that same time frame. And so there's been this switching going on. It should be a benefit for the climate. On a per BTU basis, natural gas has about half the climate impact that coal does. But that's all dependent upon whether or not that methane is leaking out before it gets to the power plant. If that's happening at too high of a rate, then that benefit is completely washed out, and it could actually be worse. So about a decade ago, EDF started trying to figure out just how big is this problem? No one at that point had really gone out and done bench science to actually measure how much is leaking out. What EPA had been requiring companies to do, and what still is the basis of the inventories today, is modeling. Estimating these leaks by saying, we think this piece of equipment leaks this much, count up how many that type of equipment you have on your site, multiply by this, and that's what you report to us. That's fine, but what it turns out is those are 30-year-old modeling assumptions that don't really reflect the modern oil and gas industry and what's going on. They were created, for instance, before the advent of hydraulic fracturing and directional drilling, which is how we do oil and gas development these days. And when we went out and did these studies with leading academic institutions and, in some cases, the oil and gas industry themselves that granted access to their sites, where we could go out and literally bag pieces of equipment and measure how much methane was being emitted, we found out it was about a 60% undercount. So, a bigger problem than the inventories would have you understand. That's great, and that shows the importance of ground-based data. MethaneSAT sort of the next natural step in that evolution, taking that and putting it into space so that we can see what's going on all around the globe. So MethaneSAT is actually the finishing touches are being put on it right now at Ball Aerospace in Boulder, where I work. Actually, I work in Boulder, not at Ball Aerospace. But which is pretty exciting. I actually got to go and put on one of these crazy-looking bunny suits and go into the clean room and see it. And it was a real thrill for me to get to see something that's soon going to be up in space, helping me do my job. So early next year, that'll be up there, and it will be streaming data back to Earth so we can understand what's going on. This is just a sense of sort of how MethaneSAT fits into the ecosystem of satellites. So there are satellites up there today. One is from the European Space Agency called TRPOMI that can detect methane emissions. It's more of a wide-angle lens. So it can scan large areas relatively quickly and show at a sort of a coarse resolution what's going on across those areas. There are satellites like GHGSat, which are like telephoto lenses. They focus in on very precise areas, and they can find problems there. But they don't know where to look unless you tell them where to look. MethaneSAT's going to sort of fit in this middle niche, and it is going to be very good at finding area emissions. So looking at a basin, for instance, like the Permian Basin in West Texas and southeastern New Mexico, which is now the most active drilling basin in the United States, and figure out what's going on across that basin and measure the flux over time and show if things are getting better or getting worse, which is going to be, I think, really helpful in a number of case scenarios. So again, this is showing sort of how MethaneSAT's going to work and its resolution and its ability to sort of track in that sort of middle niche that I was talking about. Why are finding these sort of area sources important? So folks may have heard about super emitters. Those are big leaks that need to get fixed really quickly. For instance, there was this Nord Stream pipeline rupture, which may or may not have been an act of terrorism last year. And folks, that was all over the news. It was in the Baltic Sea. There are, not quite that big, but there are big leaks like that crop up from time to time in the oil and gas industry all over the world. And those are a big and important part of the problem that satellites and other detection technologies can help fix. As big of a problem, though, are smaller individual leaks that sum up across these vast numbers of oil and gas wells into a big piece of the overall pie. So a colleague of mine, Mark O'Mara, went out and looked at this and tried to quantify how big of a problem these individually smaller leaks are. And what he found was these smaller wells with smaller leaks, they only account for about 6% of oil and gas production in the US, but sum them up and they account for half of well site emissions. So this is sort of the bread and butter of MethaneSAT, is helping us find these areas. And then, you know, those sort of pinpoint accuracy satellites like GHGSat in some instances, we can help them focus in on where to look and then get someone deployed out there to go out and fix it. This just is a sense of sort of the global scale. You know, with a satellite, you can see all over the globe and figure out where the problems are. In part because of the science that EDF's been doing over the past decade, we have a fairly good sense of where the problems are in the US. There are parts of the globe, though, that don't like to share data, or that we don't really trust the data that they share. Russia is an example of that. They, you know, in their reporting on methane emissions from the vast amounts of oil and gas that are developed in Russia, there's a lot of zeros that they report. And you sort of scratch your head and wonder if that's actually accurate. Satellites can see these problems across borders. And so for areas like that, it's going to be a powerful tool in terms of, you know, generating action to limit the pollution. And this is all because we're a nonprofit. This data will be publicly accessible at the low price of free. So you know, researchers, you know, academics, the industry itself, the public at large will have access to this data and be able to understand, you know, what's going on in their backyard, what's going on in other parts of the world, and you know, help to generate action based upon that. You know, to give a couple of use case examples, regulators will be able to access this data and potentially use it in enforcement actions, or at least use it in, you know, a sort of a quick scan to figure out where they'd like to go and take a closer look and do an inspection. Nonprofits and community groups, like I work for, can use this in terms of understanding how and where to advocate for stronger regulations and draw attention to problems. I worked in New Mexico previously and have continued to work there in my current role. And there was satellite data from an earlier satellite called Skiamaki that found a hotspot of methane emissions over the Four Corners region of New Mexico. And that image of that big red bullseye over northwest New Mexico was incredibly powerful in terms of driving action at the state. And the state now has rules in place to limit pollution from methane. And I think you can trace a lot of that back to that imagery, which shows how, you know, when you make something visible, when people can see it, it drives action. I think I'm just going to skip by this one. And so satellites are great. We also are mounting the same piece of equipment onto a plane. This is actually a Learjet that was retired from an oil and gas executive who used it to fly his wife around on shopping trips, apparently. And now it's going to have or actually now it has this sensor on it. The same sensor that's going to be on MethaneSAT is on this Learjet, and we are mapping 80% of oil and gas development in the US with this, which again is going to be publicly available early next year. This shows where it's looking. You can see there the Permian, sort of in the you know, the southwest, is the biggest or one of the biggest areas of oil and gas development in the U.S. The Appalachian region, stretching up into Pennsylvania, Ohio, West Virginia, is also another biggie that I think the data is going to be quite important from. This kind of shows you what the data looks like. The plane flies what they call sort of a lawnmower pattern back and forth to try and figure out and map the methane emissions. And then you can see here what a plume looks like when you see something emanating from a site and then blowing a little bit downwind. And then finally, you know, data for data's sake is great and important. But it is also, the reason we're doing this is because we want to drive action. We want to see efforts made to find these problems and get them fixed. And so Colorado and New Mexico are two states that have been really leaders in this regard, getting state level rules in place. Colorado starting in 2014 and continuing up through today with several improvements. The first state to directly regulate methane emissions from oil and gas development. New Mexico, just in the past few years, has caught up and has great rules in place as well. Coming soon, the Environmental Protection Agency all across the US will have final rules in place. This ought to be finalized, we think, in the next month or two, probably right around the time of COP, which is late November, and is going to be very, very important. This is taking sort of the learning and the foundation that these states have built and making that applicable all across the US. So even states that haven't acted, that are big sources of emissions like Texas, are going to have to do better and limit this pollution because of the leadership of the Biden administration in getting this done. So very excited to get those in place. And I think that's it. Thank you.